Keith is a long-time thought worker. He's a thought leader in this area, and he's a published author. He published a book called Infrastructure as a Code. The second edition of that book has been just published a few months ago. So if you haven't checked out, please do check it out. Another speaker that we have who is pairing with Keith is Ankit. Ankit is also a full stack developer, a long-time thought worker, very passionate about infrastructure. Ankit is currently working as a tech lead on a Singapore government project where the team is building a platform in AWS cloud where they're using a Terraform scripting to do the automation of the infrastructure. Ankit also comes from the northern part of India, which is called Lucknow, which is really famous for its delicious kebabs. What Ankit promised me is that the talk that Keith and he is going to give is going to be absolutely mouth-watering, just as mouth-watering as those kebabs from the Lucknow. So I'm really expecting a lot from you folks. So I'm going to hand over to Keith and Ankit, both of you, take it over.
All right, thanks, Harshal. And I hope everyone's awake now with those exercises. It might be helpful. We're going to be talking about infrastructure as code. It might be a little bit, a problem sometimes to keep awake, but hopefully it's an exciting topic. Right, it's nice to have followed on from Gregor Hope's talk because he's actually a lot of the kind of remove constraints, right? Cost and capacity and these sorts of things, and also to enable things like flexibility and innovation and time to market. However, what we have to worry about when we move into the cloud is there are risks, right? There are new things that we need to worry about in the cloud. We need to learn how to manage things like security in the cloud in different ways, different threats. We need to learn how to handle the trade-offs of moving quickly and adapting and innovating while also maintaining stability, operational quality, and these kinds of things. And often there's a natural tendency to think of there being a trade-off between quality and speed. And what we're gonna talk about in a moment is that this is actually a false idea of a trade-off. So this is the idea that, well, if you want to move quickly, that means you have to accept lower quality. And on the other hand, if you want to focus on quality, if this is your most important thing to focus on, then that means you have to accept going slowly. I heard Tao mentioning this earlier, Accelerate and State of the DevOps report and their studies of high-performing organizations. And so one of the kind of themes that we have and that you'll probably have heard about before is the 4 key metrics that comes from that book. And what that is they've identified, so I'll just take it back a moment, in their research, they've identified 4 attributes that organizations tend to, that you can measure that tend to correlate to high performance in an organization, high performance in terms of whatever it is that the organization is looking for a commercial organization, is commercial performance and these sorts of things. And other organizations like public sector and so on, they have other goals. Whatever their goals are, these 4 metrics tend to correlate with those. For example, often you make changes to your system, and then how long does it take you from having the idea of we need to make a change to actually getting that into production? In their research, actually, they focus on lead time from and committing that and getting that into production, but it still tends to apply. And these can roughly be correlated to throughput or the speed question, right? These mean that you're going fast, you're deploying more frequently, more quickly. And I mean, the other 2 metrics are around how often do your changes fail? How often when you go and to deploy a change, does it crash or cause an issue? And then how quickly when you do have a failure, whether it's because of a change or other reasons, how quickly can you restore service and get it back up and operational, your mean time to recover? And those can be correlated to stability or quality, right? So you can think about these, that research, if that continuum, that trade-off that we saw is true, then you would think that some organizations are good at one of these pairs and some organizations are good at the other. But actually what the research found is that this is not true. The highest performing organizations are good at both of those things, at all four of those metrics. And they also found that there are not organizations out there that perform well on one set of those metrics and not well on the others. In other words, you can't pick one or the other. Either you're going to do good at both of those things, or you're going to do poorly at both of those things. And that's because those are self-reinforcing, that the ability to make changes is something that you use to improve your quality. And the faster and easier it is to make changes, the faster you can improve your quality and fix things. And also the better the quality of your system and the better the design, the easier it is to make changes, and therefore you can go faster and more quickly. And so this idea that speed and quality are supporting and that the ability to make changes is important to this is underpinning our talk, and it's expressed well in the book by several of our colleagues, Building Evolutionary Architectures. The idea of this is we can't avoid change, and in fact, we shouldn't look at change as a risk, as a problem, something to be managed, something to be controlled, but something to be harnessed and used for an advantage. And so we have to build our systems in ways that make them easy to change, make them quick to change, and reliable to change. Again, going back to those four key metrics. And this is the idea of evolutionary architecture. So what we'll be talking about today is how to use infrastructure as code to achieve this dynamic. In terms of infrastructure. Firstly, defining everything as code, and that's the kind of the obvious thing. It's the name of infrastructure as code suggests this, right? So we'll talk a little bit about that. And then there's continuously testing and delivering. And so this is taking principles that we have from agile engineering of software, things like test-driven development, continuous integration, continuous delivery, and using them for our infrastructure code as well as our application code. And then thirdly, it's around the architecture and design of our infrastructure for our systems, building it with small components that are loosely coupled. So those, the benefits of doing this are that our system implementation is visible, meaning anybody can have a look at the code and understand how the system is built and what's involved. It's reusable, which is a really important thing. The idea that we can write some infrastructure code and we can use that to replicate it, whether that's across environments or whether that's for different applications, different services, which might have similar infrastructural needs. And that things are consistent, so the infrastructure across environments are built in consistent ways. So when we deploy to a test environment, we know we can then deploy our application to a production that we run in a non-production environment will reflect the behavior of the software as it's deployed on the infrastructure in production as well. And then of course, testable is underlying that, the idea that we can test our infrastructure code before we make changes to production. And these correlate back to those four key metrics. So if we have our infrastructure defined as code, we can make changes very, very quickly with a shorter time because we have more confidence that we can do it. So we can do it more frequently as well. It should be fewer failures. It should be, because we can test our code before we apply it to production, we should have fewer failures in production due to changes to infrastructure or behavior of infrastructure and applications. And then thirdly, I knew that was going to happen, the recovery time, that because things are defined as code, is very easy quickly, and that can help us. And just to give a kind of flavor of where infrastructure as code fits into the thing, if you think of your infrastructure platform, and this applies whether you're using a public cloud like AWS or Google Cloud or Azure or what have you, or Alibaba Cloud, it's also applicable in data centers where you can implement automation of physical hardware and these kinds of things. So you think about the different types of resources, whether it's public or cloud or data center. Infrastructure as code lets us define aggregate these resources, basically assemble different infrastructure resources from the platform into what you can call stacks, like an infrastructure project, and then use those as environments, use those for deploying and running our applications. And so these are kind of typically the tools used at this level. There are other tools that are used to configure servers and so on, but at the level of taking cloud infrastructure, these are the typical. Now I'll hand over to Ankit, who will talk a bit about the testing and delivery parts of this.
Right. Thanks, Keith. So, and thanks for that really kind introduction, Harshal. So let me see if I've got control of the screen now. Right. Was that me, Keith?
Yep, that was you. My hands were.
Okay. Right, thank you. Right, so continuously test and deliver everything. So we'll get into a bit of details now. So I think what would be nice for us would be to, sorry, give me a second. Yeah, it's fine now. What would be nice for us is to now work with a example, simple infrastructure project so that we can really visualize the consequences of the decisions that we're going to talk about for infrastructure delivery. So for our sample project today, it's quite straightforward. It's like our stack is Terraform. This is really the principles and that should be applicable across any tech stack. So just to describe it a little bit before we go into the details, it's like maybe you have an external facing load balancer with some VMs behind it that host your reverse proxy. This could be the entry point for user traffic into your system. You can have another load balancer with some VMs behind it that host your perhaps Java application. There could be your application layer, a database behind that, which is a database layer, and a bastion box off to the side that helps you do some DB administration or call some admin APIs or any kind of sysops workflow that you don't really want to expose APIs to your users. So right now, while we have defined everything as code, we have got really, really good visibility because everything is configured and visible in that one Terraform configuration. For our platform here, it's this main.tf. But let's see what we can do for things like reusability, consistency, and testability. Like Keith said, one of my favorite interpretations of infrastructure as code is actually applying principles of continuous software delivery to infrastructure. And one of those principles is test everything, test all changes. So these tests in terms of infrastructure would mean that we go beyond just say perhaps running a Terraform plan. You actually want to be testing against your behavior. In the case of a sample project, you're testing, can my load balancer talk to my reverse proxy? Can my reverse proxy talk to my application? Can the application talk to the database? So you're constantly validating your infrastructure changes and every single change for correctness of behavior. So, so in combination of validating all these, in combination of testing every single change, what we also want to do is enforce a behavior that only tested and validated infrastructure code is now promoted across all environments. So that would mean that we are testing for correctness of behavior and only the correctly behaving code then goes downstream to say staging and production. So how would we enforce something like this in our project, like our sample project that we spoke about? Well, the first thing we need is environments. So the simplest way to set it up from that one main.tf would perhaps be in the same Terraform project. So this is the same Terraform plan and apply. We have perhaps 3 files or 1 file, each containing the definition of the environment. But this is obviously not very good. There's no real isolation between a test and a production environment. I'm quite likely to go in and blow up the production database when I'm trying to maybe perform some experiments or push some change to test. There's no real way to really control who gets to deploy to which environment, or if you want to maybe isolate environments even by AWS accounts, that would become either difficult or impossible. So there is no real concept here of promoting changes, and all changes are part of this one big Terraform project. So what we also want to do is think about how we can isolate the states and resources across environments. So the next logical step that a lot of teams go to, and I have done in previous projects, is something like this, where we divide a Terraform project up into 3 different projects, each project mapping to an environment. So each of these projects now is its own instance of Terraform plan and apply. A test contains the definitions for the test environment, staging for staging, and production for production. So on the surface, this looks like it's worked, and this is where a lot of teams come to and stop. But we probably want to think about, are we able to enforce the behavior we need? Like, what does it mean for actually promoting changes or promoting code now if we structured our infra project like this? What it actually means is that changes, when they need to be promoted, actually need to be copy pasted manually from the test main.tf to staging, and from staging to production, which means that we're actually relying on a human being or a manual promotion of changes. We can argue that we can reduce the surface of how many things need to be copy pasted by really aggressively using modules. If this doesn't make sense right now because we haven't spoken about modules, that's fine. At the end of the day, there is no escaping the fact that we still rely on human intervention to be promoting these changes. And we can't really enforce that, okay, only when changes tested and all the tests are green in test, do they go to staging, and when they're validated in staging, do they go to production? So this problem can get even worse as we scale our projects. Say we have like a lot of resources, a lot of changes in flight together, what changes need to be mixed, matched, and copy pasted where. And also there's a chance that becomes almost a certainty as we scale, that unvalidated changes or changes not meant for production get copy pasted into the prod main.tf file. So what we want to do to solve this is perhaps something like this. So we've had like reasonable success with something like this, where we have one Terraform project or one project definition, and we promote the exact same piece of code across staging, test, staging, and production. So changes go to test. When they go green, they go to staging. When that's validated, it goes to production. It's always the same piece of code. So we eliminate the need of human intervention, and hence we eliminate the need of sort of relying on human discipline, which is notoriously unreliable, especially as teams scale. To do this, what you'll need is you can also have like environment specific configuration. Instances can be smaller in test and larger in production. So you need some kind of plumbing or scripting, make, rake, or bash files to sort of be able to tell your CI/CD jobs which environment configuration needs to be applied in which job or pipeline definition. A good resource to look at is, say, Gruntworks TerraGrunt and Terraform Workspaces, both of which try to apply this principle. And the TLDR of this part is that if we can test all our changes, we can validate the correctness of behavior, and we can enforce that only validated code is promoted downstream, then we are more likely to have production and all our environments consistent with the correct behavior. Right. Yeah, over to you, Keith, maybe for the next steps. Yeah.
Okay. So now we want to look at what Ankit just described around how you kind of do testing and have pipelines for infrastructures. As your infrastructure grows, it tends to become more difficult, right? You need to think about how to manage more complex code bases. So projects can become very big. And there are some different kinds of challenges for this. The first set of challenges that we're going to look at are around the complexity of just managing that much code and understanding it and making changes to it. How do we kind of organize the code? How do we avoid mistakes? So if we have a very large project and a bunch of code and we're pushing it across environments, it can affect the lead time for changes, because it can be a very, it could take a long time to kind of make the change, and then also to test the change across all of the infrastructure in the project and make sure that it's correct, and then it doesn't have unintended consequences to other parts of that project, which then again creates that cycle of, well, we can't make changes as frequently because it's too work intensive to make changes, so we do it less often. And going back to the original kind of premise of what we said at the start, if we're making changes less often, that means it makes it harder to maintain high quality, because it makes it harder to make fixes routinely and easily. And so you make fixes less often, you kind of accumulate more technical debt. And also you can have more failures. You're more likely to have failures to your changes. Again, if you've got a large project and you're trying to work with code changes, you might break something else that you didn't expect. And so that can create production issues. And again, the recovery time can be difficult when you're trying to rebuild things in a large project. So what we want to do is we want to split our systems up. So if we think about, we have the Terraform project. So Ankit showed that code of a project, a single project with some different things going on, and he'll give some details onto this shortly. But the essence is we want to break this into smaller composable pieces of infrastructure rather than one piece. And so Ankit will talk a little bit more about, he touched earlier on modules, so he'll talk a little bit more about how we can use modules to solve and address these challenges of the size of a project.
Right, thanks, Keith. So, all right, so we want to now start thinking about, oops, let me see if I have control.
You have it now?
Right. I think we're good, right? Okay, so this is where we were, right? We have everything defined, we're testing all our changes, and we're sort of enforcing the behavior we want. Thinking about how to, before we end up with scaling issues, and as the project goes and we add more components, before we end up with a big unmanageable ball of mud in our single Terraform project, we want to start thinking about how we can cut our infrastructure or carve it up into reusable logical grouping of components that have a strong interface with one another. So maybe you want to visualize your infrastructure like something like this, where each of these units is like a reusable grouping of components. It has an interface, which means it takes an input and gives you an output. So you want to, and these essentially will be like these, and this is what we're talking about when we're talking about modules. So if we take this in principle back to a sample project, what we can try to do is like maybe cut it up according to the outermost, and VMs become a reverse proxy module. The ones behind that become an application module. And then we have a database module, and we have an administration module or a bastion box module off to the side. So this feels like a good enough modularization of the infrastructure we have. So the next thing is like, okay, doing this, what does this mean for our delivery? Well, the first thing it means is that our ability to test is now greater because we can test modules in isolation. A lot of open source projects follow this pattern where in a module, they'll have perhaps a directory called example where they instantiate that module alone and then run tests on that module. What that means is that each module itself is independently tested. So our delivery can end up, and then this module becomes like a unit of test for our infrastructure project. And then our delivery ends up looking a little bit nicer with something like this, where each of these modules is being tested earlier on the left-hand side. So when they all come together, they have at least been validated for like their own internal behavior. If we are going to break, we are probably going to break earlier, and we're probably going to break, like we have an opportunity now to fail fast and fail early. And also if we do fail, we'll probably fail earlier. So we know where we have failed, as opposed to something breaking when all the modules have come together in that one big environment and us start digging through that ball of mud to figure out what's broken and where. So naturally, this leads itself to us having a better throughput by simply having tighter feedback loops. Testability of modules also feeds into what most folks talk about when they talk about modules, which is reusability. So we can imagine a scenario where we're trying to onboard just another application onto this platform. We already have an application module, so perhaps it's as simple as invoking another instance of that application module. Now, if this module has already been tested in isolation or like tested as well, we don't really need to worry about the internal details or implementation of this module. We just need to worry about what's the contract or what's the interface to use this module. We should function with the confidence that the load balancer and the VMs that spin up will be able to talk to each other inside this module itself. So between these two things, we can derive a lot of benefit from just starting to split the system up by using modules. but there is a few more steps we can take to make delivery even nicer. So for that, back to Keith.
Okay, thanks, Ankit. So as Ankit says, having modules helps us because it helps us to organize our code and make it easier to kind of manage different aspects of our code and reuse elements of it. It doesn't entirely solve the problem of a very large infrastructure project, though, because whether it's modules with Terraform, it's also with other infrastructure as code tools. So for example, you have maybe nested stacks with CloudFormation and so on. When you actually run the tool and apply that project's code to an environment, to an instance of the stack, all of those modules come together and you still potentially have a very large piece of infrastructure. The Evolutionary Architectures book that we touched on earlier talks about the architectural quantum. And what that is what is the unit of stuff that you change as a group, as a unit. And so at the end of the day, even with modules, your Terraform project is still one project, and that's the quantum that you work with. So what can tend to happen when you have a very large project like this is it can take a long time to apply. Oops, sorry, I'll just go back and actually I think I can't remember. So what we want to do is we want to have it more decoupled in terms of the actual deployment and what we're running. And so just to kind of give a little bit more context of the reasons that we want to do that, the time that it takes to run the apply command can be very long. I've worked with one organization here in the UK where it took over an hour and sometimes 2 hours to run Terraform apply on their project. They had RDS, they had like about 50 or 60 RDS instances as a part of their overall estate. They had like something on the order of 10 to 15 different application teams, all deploying applications onto the infrastructure, and the infrastructure was one big project. So what we worked on with them to do was to break that apart. And so the way we broke it apart was not just in terms of modules, but to take it further and say, let's break it apart into separate stack projects, separate Terraform projects. So that kind of estate, that set of infrastructure now became multiple Terraform projects. And this meant that we could individually test and deliver each of those stacks on their own. So you would have a stack, for instance, that application stack, that you would have a pipeline that instantiates it by itself in a test instance, run some tests against it, and exactly the same way that Ankit was talking about the modules and saying that, oh, we can fail fast, we can get fast feedback on whether the module is correct. We can now do that on the individual stack level. So the individual, say that application stack, or however we're going to divide it up, which we'll talk about in a moment. Each of those pieces, you can kind of make sure that that's correct before you then put it into an environment where they're all integrated together. And so in terms of thinking about how to divide up that large Terraform project, there are a few different kind of lenses, a few different kind of things you can think about. And it tends to be in practice that you combine these things to come up with what's the right way to divide things, and you evolve them. So you divide things up, and then over time you learn things about it and realize you need to kind of make changes to how you do that. So one way to do it is to look at the patterns of change. What things tend to change together? What pieces of your infrastructure do you tend to change together as a part of a single, something that you're trying to do when you make a change? Well, we need to touch this and this. And so when you group those things that change frequently together into a single unit, this is what we talk about when in software design, you talk about cohesiveness. You have loose coupling where you break things apart, but then also the opposite is cohesiveness, where a component has things that tend to work together and be related together. And you can often look at your Terraform code and look at what are the things that are referring to each other, and the things where there's lots of references between things, those are often things that you want to kind of group together into a single project, so that when you make a change, it's not potentially affecting so many other projects. You can also look at your team structures, your organizational structures. So this is going to the idea of Conway's law, which, if you haven't heard it, is often cited in architecture, particularly around microservices, which is just the idea that architecture of a system, the design of a system, tends to reflect the design of a team, like the team structures. And so you can use that to your advantage and think about, okay, which teams, what teams need to be able to manage which parts of the system, applications and infrastructure, and group those together to minimize the amount of times where when making a change, we've got to go and coordinate effort across teams, which can then become that creates a lot of overhead and friction for making changes. And so related to that is thinking about governance of the different parts of your infrastructure. So for example, you may be in a regulated industry, and there may be some parts of your system which are subject to certain regulations. Examples of that include in finance, there's obviously things like PCI compliance if you're handling credit card data. So you might look at the parts of your infrastructure that are involved in managing the credit card numbers and data and those sorts of things, and say, let's put those into their own projects so we can handle the governance and also report and audit based on that infrastructure project that's handling those. And then other parts of the infrastructure which aren't actually touching those aren't subject, aren't subject to those regulations. You don't need to have quite as stringent the requirements on those. So that makes it very easy. It also makes it simplifies reporting, because when you have, say, an auditor coming in to check compliance, you can say, here's the parts of the system that you need to look at, and they can verify other parts of the system don't actually handle things, but that's a simpler task for them. It just simplifies that whole process. And then a third, or a fourth rather, lens of thinking about how to divide infrastructure can be around the resilience. What are your scenarios when you have failures, and how you recover things? And also a related thing is scalability. So if you think about, there are parts of the infrastructure which might fail and we want to be able to rebuild quickly, can we separate those out? So for example, you might have the database. The way that you handle resilience for that is different, because you need to make sure that the data is backed up somewhere. And when you rebuild that, then you need to kind of restore the data in some fashion as a part of that. Maybe the networking is on a different cycle. So you might be able to then rebuild networking if there's some kind of a problem with that, without having to rebuild the database or worry that when you run that Terraform apply command, it might affect other things that are not related. And similar with the scaling thing, where there are parts of your infrastructure where as the load increases, the usage increases, you might need to replicate some parts of your infrastructure, but you don't need to replicate everything. So that's another kind of way that you might split things up a bit. So now it's back to Ankit.
All right, thanks, Keith. So let me test my control again. Right, I suspect it's working. Okay, so, right. So modules got us as far as they got us. And now we really want to start thinking about, as we scale, like Keith said, how do we, and if we're ever going to scale to like 60 RDSs in one Terraform project, how do we think about like splitting that thing out? So it's like not one monster Terraform project that we are applying, and then everybody in the whole org is nervous every time you go to click that button to apply it. So we want to head from a visual that perhaps looks something like this to maybe something that looks like this, where each of these is a stack in itself. It could be invoking one or more modules. So this is just one of the ways that we could carve this Arc sample project up. It's not the right way, and all the right way depends on the things that Keith listed out about how you want to balance organizational units with resilience and all that stuff. But for the sake of our example, perhaps we could have an application stack where the application VMs and the DB modules are invoked. Perhaps they have really high cohesion between them. We could have a DMZ stack that's just the front-facing load balancer and the VMs that host your reverse proxy. You can have an administration stack, which is the Bastion box or the jump host or the VPN into the system and any networking related to that. And each of these stacks then themselves is individually Terraform plan and applicable. So what does that mean for our delivery? So our delivery, which was previously something like this, where we are delivering this huge monolithic beast stack into production, goes to something like this, where we have split up stacks that are individually releasable, and ideally folks in the teams can work parallelly without interrupting each other to release changes or features across all of these stacks. And all of these then come together to form one environment. So what does that mean for us, perhaps from the point of view of the 4 key metrics and like the impact it will have on our delivery? The first thing that's sort of easy to visualize is the fact that we should probably see better lead times and higher deployment frequencies. From being able to not have to be dependent on what's happening across, say, other stacks here and here. Say we only want to release a small change, like perhaps there is an OS update or a critical patch needed where we need to update the AMI or the OS image of one particular group of VMs. But in flight at the same time, as another team member or different team that are performing some database update that will cause downtime and hence cannot be done on Monday or Tuesday or Wednesday, it needs to be done on Saturday. So now splitting things up like this means that it's possible now for that critical patch to not have to wait on other in-flight changes or be coupled with them, or any other changes have to be timed along with this. It can be individually tested. The AMI could be like the config, or the AMI ID could simply be injected and tested into the DMZ stack perhaps and delivered into production, independent of whatever was happening in other stacks or whatever features were in flight or in dev and other stacks at the same time. So this means we can start thinking about delivering smaller changes with a higher frequency. We can start moving away from perhaps monthly or quarterly change windows for infrastructure, which have a huge delta of changes that needs to go in all at the same time. In our experience, and it's like there's a case to be made that we should also see a positive impact on like a time to recovery and a reduced failure rate because of splitting our stacks and delivering them individually. A simple example could be something like perhaps we are doing some kind of networking tightening or like IP whitelisting or blacklisting for our external most layer, like the DMZ layer. And IPs could be different across environments. So there's a chance this didn't get caught in a lower environment in a test. So if there is a stage that we have engineered where we get to review the plan of a Terraform plan and apply before the change goes into production, the chance of us catching this misconfiguration is much higher now, rather than if we still got to review the plan, but the plan for all the faster and our deployment frequency is higher, which means we're delivering small changes, then perhaps this is the only change we're delivering in this production deployment. We're only updating an IP whitelist. So the chances of then catching misconfiguration in this last safety net is even higher. Say we don't catch it. Say we do deliver, say, broken code or like incorrect behavior into production, and we're blocking now user traffic from being able to reach the system. What will probably happen is some health check somewhere will start flashing red. And at this time, if it is a small stack with frequent deployments, we can simply revert or reapply the previous version of this stack, which will undo our changes and resume availability for our system. Now, this would maybe not have been possible if we were applying as part of a huge stack with infrequent changes. In the case of, say, you applied the wrong networking rule and in the same push 60 databases are also updating at the same time, or you'll have to sit there and painfully wait for hours before that Terraform apply could finish before you could revert your change and and recover availability for the system. So splitting stacks should mean good things for all 4 of our key metrics, also showing like it goes back to show the correlation between all these 4 key metrics, that they usually end up going together. Something else that happens when you split stacks, like they'll start thinking about splitting stacks, especially according to, say, organizational units, is scalability. There will come a time where the infra project grows so big that the small infrastructure team that started it off ends up being the bottleneck to the org. The lead time for changes delivered by this team are really high, and the application team can't get their dependencies in time to deliver value for the organization. At this time, if we have split stacks or are going to split stacks, we can simply extract those stacks to their own repositories, each owned. Then all these teams can perhaps now work in parallel because these stacks themselves are individually releasable. As things grow, as teams grow and number of teams grow in the org, our ability to work with like a small high trust unit will also diminish. oh, wait, sorry, give me a second. I think, yep, there we go. Our ability to work as a small unit will also, like high trust unit will also diminish. So then having these individual pipelines that deploy these stacks could also mean that we can enforce our governance structures and apply role-based access control for who can deploy what. Maybe the platform or the networking team can apply the reverse proxy, and the database team or something, or an application plus database DevOps team can apply the application stack. We can even enforce fine-grained permissions for the agents that actually do the deployment, further isolating different teams from blocking or interrupting each other. Should mean safety plus throughput. Right. Finally, cutting things up into smaller pieces also gives us an opportunity to test a little bit cheaper. So if we can spin up a stack on its own, now we can test just that stack on its own. We can assume that perhaps if we spin up the application stack, which has 2 modules, perhaps they're already tested, but we can do an integration test, like can the application VM reach the database on the database port? Like, does the networking connectivity work between the two? And when we deploy the whole environment, this gives us an opportunity to run the last few remaining end-to-end tests that basically test the integration across all our stacks. Not to go like, so just to summarize, what the point being that we probably want to start thinking beyond modules and about how we can split our stacks up, especially if we want to think about how we want to scale our infrastructure project and our infrastructure teams for the all. So that's all from me. I think I'll hand off to Keith to take us home.
Okay, so just the key points kind of to reiterate. We talked about defining everything as code, and that's something that helps us to be able to continuously test and deliver that infrastructure as code. And also an enabler for being able to continuously test and deliver our code, get fast feedback, and scale up large is having these small, loosely coupled components of infrastructure and aligning those well. How we know if we're doing this well comes back to those 4 key metrics. And again, what these boil down to is we want to be able to make changes frequently so that we can have higher quality, we can fix things and continuously improve our quality and our reliability, which means, again, in a circular kind of a cycle that helps us to release more frequently and more quickly, which helps us deliver value and to experiment and support the business or the organization in achieving their objectives, innovating, trying new things, learning what works, making improvements. So this is all kind of leading up to that, you know, the value is really in. And just to kind of finish up, one last kind of point is this isn't necessarily easy. It's not a magic fix, right? There are challenges that you need to address in order to make this work. One is that it does increase complexity. So by taking an infrastructure project, breaking it into multiple pieces, you now need to think about things like, well, how do you integrate? When you have dependencies between these different infrastructure stacks, how do you manage those dependencies? How do you test? So we showed those separate pipelines. Well, how do you make sure that when you deploy a stack, and there are a lot of techniques largely drawn from software, the world of software design and architecture and these kind of things. So things like that we have to apply to infrastructure, and managing changes to live infrastructure can be very scary. So there are techniques that, for example, and these are in the infrastructure as code book. I tend to go into more detail on these things, but things like drawing from ways that we've had to make agile ways to make changes to data, applying those to infrastructure, that kind of expand and contract pattern. And touching back on what Gregor was talking about architect decisions. So in order to work in this way, it's not enough just to say, okay, we need to build things like this. It means that we need to think about those principles that we use to make decisions about our architecture at all levels, applications and product selection and all these kinds of things. We have to take those decisions with a lens on how do we support this kind of decoupled way of building and managing our infrastructure and our systems as a whole. So it's important to think about these with that and to make sure that we're driving those throughout, because if you do this just in infrastructure on its own without looking at the larger organization, it's not going to work very well. These things have to complement each other. And that means changing our practices, how we work with infrastructure, even for teams that are using infrastructure as code tools. How do you do things like write tests for these and make that a routine part of your ways of working? And then finally, it's about the maturity of those practices. So you often hear things about, you must be this tall, for instance, to use microservices as an architectural approach. Similarly, with this kind of stuff, you have to kind of get across your organization and the way that you manage different parts of things. You have to kind of focus on this and make sure that you're able to do this. So thank you very much. It's been a pleasure talking to you all. And we'll be hopping into the Slack chat, I think, for a little while to take any follow-up questions.
Yeah, thank you.
Thank you. Thank you, Keith. Thank you, Keith. Thank you, Ankit. Well, that was a very powerful session. I think the details and the specifics that you shared, all the details and everything, I'm sure that our attendees are much appreciating this fact. As Keith just mentioned, that even though we are basically finishing the day off with this session, they are still going to be hanging around to answer your question. If you have any question, you can still post them on a Slack channel. Keith and Ankit will be there to answer your questions.